Okay, this is a short lesson on gears and gear ratios, specifically how to calculate gear ratios in a couple of different systems. Now, to start off with, this lesson is only going to look at three basic gear systems. You have a simple gear train, which is simply two gear wheels which are meshed together. You have an idler gear, where you add in one or more gears to an existing gear system, and I'll come to that at that slide. And then finally you have a compound gear train, which from an engineering point of view is probably the most common type of gear system you'd find. Now, compound gears are specifically for Leaving Cert technology, so if you're junior cert technology watching this, you can ignore that section of the video. Now, we need to start off with some basic knowledge about gears. Now, every single gear system, and this is the most basic gear system you can find, which is two gears meshed together. And in every single gear system, you have two important gears. You have the driver and you have the driven. Now, the driver is the gear that is connected to your power source, whether it's an electric motor or a hand crank or whatever. And then your driven gear is connected to your output, whether it's the drive shaft on a car or the spindle on a pillar drill. It doesn't really matter. The most important thing about a gear system when we're looking at this is this point here, the point where the two gears mesh together. Now, if you're to look at this point here, what you'll notice is every time a red tooth passes that point, a green tooth also passes that point. So if I was to count one full revolution of the red gear, which is made up of 14 teeth, then at that point I would count 14 teeth passing. Now, in this case, you'll notice the two gear wheels are identical. So the green gear has 14 teeth as well. So 14 teeth pass that point on the red gear, and 14 teeth pass that point on the green gear. So in this particular situation here, the two gear wheels are turning at the same speed, because if 14 gear teeth pass on the red gear, 14 teeth also pass on the green gear. Now, the other thing I'd like you to notice is with this particular gear system, the two gears are turning in opposite directions. The red is turning clockwise while the green is turning anti-clockwise. Now, that's going to be important later when we talk about idler gears. Now, if we look at a more common situation where our two gear wheels are of different sizes, this now brings in a little complication. The red gear again still has 14 teeth, but you notice the green gear is significantly larger, and in this case has 28 teeth. Now, we're going to do the same exercise again. We're going to look at one specific point on the gears. Now, for one full revolution of the red gear, again, we're going to have 14 teeth passing that point. Now, here's the problem. In the green gear, we still only have 14 teeth passing that point, because there's only 14 red teeth for one full revolution. So if I want the green gear to go one full revolution around its axis, I need 28 teeth passing that point. And for 28 red teeth to pass that point, the red gear has to rotate twice. So in this case, every time the red gear rotates twice, the green gear only rotates once. So the smaller gear always rotates faster, and that is a handy rule of thumb when it comes to looking at equations. The smaller gear is always faster. Now, let's have a look at the equations. Now, we're going to look at our two gear systems we've looked at so far, and that is the two gears the same size, and then one gear different size to the other. Now, the equation is going to be the exact same for both. Our gear ratio is the number of teeth on the driven over the number of teeth on the driver. The driven is always on top when we're looking at gear ratios. So, if we take our simple gear system, you'll remember the red gear has 14 teeth, the green gear has 14 teeth. So, we have 14 over 14, which gives us a gear ratio of 1:1. Now, what this means in reality is that every time the red gear rotates once, the green gear will rotate once, and they're turning at the same speed. Now, if we look at our second one, it's the exact same equation, so the number of teeth doesn't matter. This time, however, our gear ratios are different. There's 28 teeth on the driven, there's only 14 teeth on the driver. So our final gear ratio here is a ratio of 2:1. So a ratio of 2:1 means that the red gear has to rotate twice for the green gear to rotate once, because the green gear has twice the number of teeth than the red gear. So our ratio here is 2:1, or a ratio of 2. Now, I've mentioned idler gears. Now this is important. An idler gear is simply a gear that is put between the driver and the driven. So again, our red gear here is the driver. Our green gear here is the driven because it's the output. Our idler gear sits in the middle between the two. Okay, what does that mean in real terms? Well, we have 14 teeth on the red, we have 28 teeth on the blue, we have 42 teeth on the green. Now, if we take our arrow again and we look at this point here, and let's say our red gear rotates once, well, that means at that point there, 14 teeth are going to pass that point. Now, I move around to here, I still only have 14 teeth passing that point because it's linked to the red gear, which means my green gear still only has 14 teeth moving. So in other words, you can actually ignore the effect of the idler gear. The idler gear that sits between the driver and the driven makes no difference to the gear ratio between the driver and the driven. And we can see this in the equation. So for our gear, we have the teeth on the driven over the teeth on the driver. We saw that there are 42 teeth on the green gear, there are 14 teeth on the red gear, giving us a gear ratio of 3:1. That means if I want this to rotate once, my red gear has to rotate 3 times, my blue gear will actually rotate 1.5 times. That's what that basically means for this to work out properly. Now, if you're a junior cert student, that is as much as you need to go. For leaving cert, you need to look at compound gears. One last little thing about idler gears. Both the red and the green gear are turning in the same direction. That's the other thing an idler gear does. If there is an odd number of gears, the two, driver and driven, will always turn in the same direction. If I added in a 4th gear, the driver and the driven would actually return in the opposite directions. So if there's an odd number of gears, driver and driven are in the same direction. If there's an even number of gears, driver and driven turn in opposite directions. Now, let's move on and have a quick chat about compound gears. Again, leaving cert only. Here we have a compound gear system. Now, you need to understand what's actually happening in a compound gear system. And the best way to understand this is we have 2 gear systems side by side. Our first gear system is made up of the red and blue gears. That's our driver and our driven. Now, if you'll notice, the yellow gear and the blue gear are turning at the exact same speed. They are connected to the same shaft, which means whatever speed the blue gear turns at, the yellow one will turn at the exact same speed. So that is our second gear system, driver 2 and driven 2. Now, principle that we've looked at so far still applies here. Count the number of teeth that pass a specific point and move that along. So we have 14 teeth on the red gear. Let's have a look at the equation here. So let's have a look at our gear ratio. The red gear has 14 teeth, the blue has 42, so that's our first gear system. So you should be able to work out the gear ratio for that. And then on our second gear, we have yellow and to green, which is 14 and 28. Now there is an equation we can use, and it is this equation here. It's the gear ratio of the first gear system multiplied by the gear ratio of the second gear system. So it's the number of teeth on the red over the number of teeth on the blue, and then multiply that by the number of teeth on the yellow over the number of teeth on the green. So let's have a look at what this looks like in real terms. Our gear ratio here is 42 over 14 multiplied by 28/14. Now this is a nice handy calculation. They won't always be that handy or that straightforward. This gives us a gear ratio for our first gear system of 3:1, meaning there's 3 times more teeth on the blue gear compared to the red gear, and then 2:1 for our second one, which means twice as many teeth on the green gear compared to the yellow gear. This gives us an overall gear ratio of 6:1. In other words, the red gear has to rotate 6 times for the green gear to rotate once. Now, you can do it that way, all as one equation. Or you can split it up into 2 halves. Work out the gear ratio of the first system, then work out the gear ratio of the second system, and then multiply those 2 gear ratios together. Why do we use this? It gives us a very large gear ratio in a small compact space. If I wanted 6:1, I'd have had to 6 times more gears or teeth on the green gear compared to the red gear. This lets us use smaller, more powerful gears compared to normal. Now, that is it. That's a short lesson on gear ratios. Hopefully that has helped you understand what's going on with them. I will do more of these, so check out the YouTube channel that's shared with you. Bye.